We are going to do linear transformations today. So there are 3 different transformations that we're going to talk about. And the way we are going to determine how they're transformed is we're going to compare them to our linear parent function. So go ahead and write this. Compare lines graphed to f of x equals x. F of x equals x is the same thing as saying y equals x. So these are linear transformations. Later we'll do quadratic transformations, but that's something new that you'll see this year compared to last year. In 8th grade, y'all saw how shapes are transformed. Like there's a shape that's graphed, and then you translate it over or down, or you reflect it up or down across the x-axis. So for linear transformations, we are comparing it back to our y equals x. This is our linear parent function. But the most famous equation in algebra is y equals mx plus b. Y equals mx plus b, we are going to look at the whole y equals, but we are going to write it in function notation. So function notation is like f of x or g of x or h of x. So there's different titles for them or names for them. For this one, it's going to be g of x equals negative a f of x plus or minus k. So honestly, this looks like Greek, right? Looks like something hard to understand. It's just mathematical. It's out of this world. But what we're going to do is we're going to break it down with each part. So the negative is what reflects the line. So a line can be reflected across the x or y axis. So remember, a reflection is like a mirror image. So it's going to go across. So with lines, it's going to go from positive slope. A reflection would be a negative slope. Instead of puff, puff, positive, it'd be nice, negative. The A actually determines the slope. Slope determines steepness. So if A is greater than 1, then your line is going to be more steep. But if A is between 0 and 1, that's what this compound inequality is. It's less steep. So the A determines steepness, kind of like slope. The plus or minus k determines shifting up and down, kind of like the y-intercept. So we are going to break it down and look at each one of these individually. We're going to start with the plus or minus k. So it's not going to have, this isn't a new symbol. This is just either plus or it's minus. So we say this as plus or minus because it could be either one. Okay, so let's look at what the linear parent function is. First off, what is a parent function? We're going to see 3 parent functions this year. So one of them is linear. So what a parent function is an original, untransformed graph. And it always goes through the origin. Remember, the origin is 0, 0. And then a linear parent function is the line parent function, the one that goes through the origin. That's the untransformed graph. And this is f of x equals x. Or we could say y equals x. This is going to be on your test on Thursday. So put a couple of stars around it. The linear parent function is the original untransformed. It's just y equals x. So with y equals x, it has a slope of 1 over 1. That's our most basic slope, 1 over 1. And then our b, it doesn't have a plus or minus number. So it's actually our b, our y-intercept is 0, which is our origin, which is what we want. So we're going to look at all the 3 transformations and then one that has many transformations on it, like all 3. So we're going to look at them separate. We're going to graph them in the calculator, graph them on paper. Don't forget, we're comparing it back to our linear parent function. All right, so the first thing we're going to look at is the vertical shift. So vertical means up and down, so vertical shift. How does the y-intercept change? That's what's being asked. So however the y-intercept is changed from 0 to something else is how it's shifted. So we are going to write this as g of x in front of the f of x equals f of x plus k. G of x equals f of x plus k. So this plus k is going to translate it up whatever the k is. So k could be 5, k could be 10, whatever it is. So translate up k units. And then whenever we have a minus k, oh, this should say g of x equals up front. When we have the minus k means go down. So translate down k units. So a plus means goes up, a minus means goes down. So the way it's going to be written is let f of x equals x, find, oh, this is written wrong. It should say f of x plus 6. Find f of x plus 6. So it's like it's saying f of x plus k. K is 6. So we could rewrite this. I'm going to name my new function after it's translated plus k units, g of x. So g of x equals whatever x was, so it's just x, and then plus the k units, so plus 6. So we need to graph this. The black one that's already graphed, that's our linear parent function. It's the one that goes through the origin, has a slope of 1 over 1. So label this f of x equals x. So plus 6 just means that this same exact line is just translated up 6 units. It has the same slope. The only thing that's changed is the y-intercept. So let's find out how that looks. So the origins here go up 1, 2, 3, 4, 5, 6. Every point is moved up 6 units. Or we can just graph it like normal. Our slope on this is 1 over 1. So let's go ahead and make all of our pretty points. So we have our y-intercept. And then our slope is, what's in front of x? 1. So it's just 1 over 1. Up 1, right 1. Make all your pretty points. And then go the opposite way. Go down 1, left 1 to make your other pretty points. Because you need all the pretty points in a line. And so they should be the exact same line, just translate it. So use your straight edge to make your line straight. Don't be lazy. You can use your journal, you can use another sheet of folded paper, or you can use that straight edge that I gave you to make your line straight. So this one is g of x equals x plus 6. So this is just a translate up 6 units. So if you were to look at this point at the origin and count up, you would find the new line. Or if you looked at this point right here, went up, find a new line. So all of these points were translated up and it created a new line. So just write translate up 6 units. We don't have enough room to write translate. If you just want to write up 6 units, that's fine too. So look at the other one. We need to graph that one too. What kind of translation is this one going to be because it's minus 5? What's minus 5 going to do? If plus 6 translated up, what's minus 5 going to do? Down, yeah. So let's go ahead and put down 5 units. So just knowing that, we can graph our line. So it's going to be down 1, 2, 3, 4, 5. It's going to have the same exact slope. Up 1 over 1. Make all your pretty points. Same slope, different y-intercept. What kind of lines are these compared to each other? Parallel, yep. Parallel lines have the same slope. Every point was translated down 5 units. So this one was my f of x. This one was my g of x. I'm just going to label them like that. Make it a little easier. Not as much writing on each graph. and if I were to graph this in the calculator, which we are going to do, I'm going to put g of x is x minus 5. It's the same thing, just minus 5. We're going to put all 3 of these in the calculator. So everybody pull up their calculator. If you need to, clear out the memory, which is second plus 712. Or you can just go to y equals and push clear on those 2. We're going to put in our parent function first. Our parent function is y equals x. So go up to y1, put in just x. I'm going to come around and check y'all's calculators. So make sure you're doing this with me. Y equals x. Then y2 is x plus 6. And then y3 is x minus 5. Make sure you use minus and not negative. The only time we put negative is if it's in front of another number. Another number is in front of it, I mean. So this right here should be a minus. It's the longer one. Now hit graph. You should have 3 graphs on there. I'll show you my again. Okay. So you should have had it look like this. And if you look at them, they're all parallel to each other. They all have the same exact slope. It's just, it moves down or up. Also, hit the button trace. Trace is right next to graph. Look at where my finger is. Hit the button trace. And you can arrow. And up here at the far left corner, it tells you what equation that is. If you arrow up, it'll show you what equation that one is. And it has different colors too. Y'all are really fortunate to have the ones with the colors. This one is the red one, so it's in too. Okay. So the next thing is the reflection. Reflection. The reflection is whenever it's changed from a positive slope to a negative slope. So this one is going to be g of x equals negative f of x. We're just going to flip the slope around. Instead of it being positive, it will be negative. So this is actually y equals negative x. So it has the same y-intercept, but instead of being up 1 over 1, it's going to be down 1, right 1 for our slope. So down 1, right 1. Down 1, right 1. Make all your pretty points. Down 1, right 1. And then go up 1, left 1 to get the other pretty points, all in a line. Connect your dots, make your line. This one's f of x. This one's g of x. And we're just using f and g as names for function notation. Go ahead and put this into y equals also. I'm just going to change y2, clear that, clear y3, and put in a negative, not minus. The negative is the one right below 3, negative x. If you get an error, it's an error because you put in minus instead of negative. Hit graph so you can see it. And it's, one's puff puff positive, the other one's nice negative. Okay, the last kind of transformation is the steepness. So you know how lines have different steepnesses? Like one increases really rapidly and one increases really slowly. So that's the steepness. It's determined by slope. So how does this slope change? So it changes according to the a value, the number in front of f of x. So g of x equals a f of x. So for it to be more steep or steeper, the a, whatever a is, has to be greater than 1. This tells us steeper or more steepness. So it's changing the slope whenever you do the a. And it's also by a certain factor. So like this one is 3f of x. So it's going to be steeper by a factor of 3. I'm just going to put steeper. But you know 3 determines like the factor. So the g of x is going to end up being 3x. G of x equals 3x. So instead of it being up 1 over 1, this one is going to be up 3 over 1. Because you're changing the slope. Your y-intercept stays the same though. So start at your origin, up 3 over 1. Make all your pretty points. Up 3 over 1. Up 3 over 1. Up 3 over 1. And then down 3 left 1. Down 3 left 1. Down 3 left 1. So see how it is steeper? There we go. So to describe steepness, you would think of, is it really, really increasing rapidly or not? My son got on the treadmill yesterday because he was supposed to run a 5K. We did this virtual 5K race, and we were going to get a medal and some new socks and stuff like that. So there was an incentive to do it. My daughter and I, we went outside to do it, but my son waited till last night, and so he had to get on the treadmill. He made the incline on that treadmill like super steep. Have y'all ever done that? Gotten on a treadmill and made your incline like really, really high? And so he was running, and he thought he could do 3 miles at a steepness like that. Guess how far he got? He actually got 1 mile. But running that after 1 mile at a steepness like that, he decided like he couldn't do it anymore. So all that to tell you, steep, it would be really hard to run up. It's going to be more difficult than something that's flat. So I'm going to put hard to run up. So if it looks like a ramp that is really hard to run up compared to the other one, then that is steeper. So it is steeper. But if it's flatter, it's easier to run. Hard to run up, which means steeper. So let's say that g of x is a f of x, but a is between 0 and 1, like this. So as we've seen with domain and range, if you have a variable in the middle and two numbers on the outside and it's less than, then that means that the a value is between 0 and 1. We don't care about negatives when we talk about steepness. Negative determines reflection. But this determines that it's less steep by a certain factor. So y equals 1/4 x. So the 1/4 is going to make it flatter or less steep. So 1/4 is going to be 1/4. So up 1, right 4. So do that. Starting at your origin, go up 1, right 1, 2, 3, 4. Up 1, right 4. And then do the complete opposite. So see how those dots are already like really kind of flat? So if my kid would have kept his incline a little bit lower, he probably could have done his 3 miles. But he didn't. Oh well. So this is flatter or less steep. So think about less steep as easier to run up. We'll do the multiple transformations tomorrow because we're kind of out of time.